Hey everybody, so we're going to be talking about linear transformations today. We're going to talk about our parent function of the linear functions, and we're going to go ahead and discuss what all we can do to kind of adjust it from that parent function. So you'll want to recall that the parent function is the simplest function for each shape in a function family. The simplest function for each shape in a function family. Now, our linear parent function is f of x equals x, or y equals x. And I want you to remember that the slope for this is 1, and your y-intercept for this is 0. And definitely also write down your parent function on the front of your notes, on the flap of this. So I'm going to write it on here. And notice I'm also writing down that my slope is 1 and my y-intercept for this is 0. And yes, it is a direct variation. All right. Now, any transformation that is going to be done to a linear equation, it's being done from this parent function. This is where it starts. Just like you guys started from your parents, that's where you came from. Yes, that's how biology works. These equations are going to be coming from the parent function. So in linear functions, graphs are reflected over the x-axis when there is a negative slope. So pretty much, if you have a negative m, then you can say that it's a reflection over the x-axis. And it doesn't matter if it's just negative x, where your slope is a negative 1, or if your slope is a negative 5. Your slope could even be a negative 3/4. And it wouldn't matter, they're all still being reflected over the x-axis. So on the front of your flap, I want you to write negative slope. If you want, you could also write negative m, but please do not write negative m like that. You're going to think it's just some type of dash when you're looking back over this later. Next, you can tell if something is steeper than the parent function. So if you're looking at it, your parent function looks like this. Let me draw it in black for y'all. It's got a slope of 1. It goes through the origin. A steeper function is going to look like this. It's getting closer and closer to the y-axis. And this is when the absolute value of the slope is more than 1. You'll also want to remember that absolute value right here means that you're only looking at the number, the distance from 0. Pretty much, you don't care if it's a positive or a negative right now to determine if it's steep or flat. If you want, on the front of this, you can also write that the absolute value of m must be greater than 1. All right. Now, let's look at these right here. This one, y equals 4x, it's only got one transformation to it. And you can say that it's steeper, and it's by a factor of 4. Your other one over here, f of x equals negative 5x. Well, guess what? There are two transformations happening. You've got the reflection over the x-axis, but you've also got a steepness to it. This negative only determines if it's a reflection over the x-axis or not. And then you can also say that it's steeper by a factor of 5. Now, you'll notice that these are both integers. It doesn't always have to be an integer. You could have, say, something like g of x equals 5 over 2x. And even though this is a fraction right here, it's still greater than 1. And therefore, it would be steeper than your parent function. So now let's talk about flatter, which is when typically most people assume, and wrongly so, that they're working with something flatter because it's got a fraction. That's not always true. Don't assume like that. This is only going to be true when the absolute value of the slope is between 0 and 1. All right, so let's look at this first one right here. This is flatter in comparison to the parent function, and you can say by a factor of 3/4. And that's because 3/4 is less than 1 whole. Now, like I told you earlier, it doesn't matter if it's a positive or a negative. That negative is just telling us that it's a reflection over the x-axis. We're only looking at the absolute value of our slope. The absolute value of negative 1/2 is just 1/2, which means it's going to be flatter since it is less than 1. So remember, just because you see a fraction, do not assume that it's flatter. And I am going to go ahead and put this on the front of my notes. And that's saying that the absolute value of your slope has to be between 0 and 1. All right, this last one is your vertical shift. All right, the b value will determine if it is a vertical shift. This is your y-intercept. If it's a positive b, meaning it's more than 0, then it's going to be vertical shift up, however many units. So for this one, this is a vertical shift, and it's up 6 units. Now, a negative b is just going to be the opposite, in that if b is less than 0, or if it's a negative value, then it's going to be a vertical shift down from the parent function, which means this equation right here, f of x, means it's going to be going down 4 units. And if you want to put vertical shift before it, you totally can. Sometimes you will see vertical shift before, sometimes you won't. So, on the front, you can either write positive b up and negative b down, or When b is greater than 0, go up, and b is less than 0, go down. I want you to do whatever's easiest for you to look at. And for me, this is what's easiest to look at when I'm just glancing at my notes. All right, so let's look at some of these examples. We are going to describe the transformations of each graph in comparison to the parent function. What I recommend when you're given a graph is that write the equation in slope-intercept form. So y equals blank x plus blank. Your y-intercept for this is 0, so it's a direct variation. We don't have to worry about it in terms of the y-intercept. And then your slope for this is going up 2 to the right 1, so it's just a 2. So you've got a slope of 2. It's not a reflection since it's going up the hill, it's positive. It is going to be steeper compared to the parent function. And if you want, you can say by a factor of 2. All right, so let's try the next one here. Okay, so let's do number 2. This one's still going through the origin. Okay, so they're kind of keeping it easy for us. And then our next point here, I'm going to start from here because I'm walking from left to right. And I notice I'm going down the hill. And I went down 2 to the right 3. So my slope is negative 2/3. And then you've got x plus 0, so I don't need to do that. Now, there are two things happening. The first thing you'll want to notice is my slope is negative, which means it's a reflection over the x-axis. Then you notice a slope of 2/3. 2/3 is more than 0, but 2/3 is less than 1, meaning it is between 0 and 1, and so we can say that this is flatter than the parent function. And you can say by a factor of 2/3. All right, let's do these next two. Right, both of these have different and multiple transformations happening as well. So let's do number 3. Y-intercept for this is 1. My slope for this is 1, 2, 3, 4, 5. Up 5 to the right 1. Because my slope is more than 1, it's going to be steeper. And then because my y-intercept is going up 1 from the origin, we're going to say it's a vertical shift. It's going up 1 unit. And those would be the transformations applied to number 3. Lastly, we've got number 4 here. This one, it's a triple whammy. So I've got y equals going downhill, down 1 to the right 4, and the y-intercept is at a negative 2. So the first thing I see here is the reflection, and it's going to reflect over the x-axis. Your slope is 1/4, negative 1/4, but we're only going to concentrate on the 1/4 to notice that it's flatter. And that means we can also say by 1/4 here. it's going down 2 because our slope, or y-intercept, I'm sorry, was a negative 2. All right? So that's what you do when you've got it with all of your graphs right here together. But it's okay. Sometimes you don't have to do all of that. Sometimes they'll just give you the equation and you have to tell me how it got there from your parent function of y equals x. Well, start from left to right. First thing, it's a reflection over the x-axis. Then you see that your slope of negative 2, concentrate on the 2, and because it's more than 1, it's going to be steeper. And you can say by 2. Your y-intercept is a positive 7. Because if it's a positive b, you're going to go up 7 units. And that's a vertical shift. And our last one is number 6 right here. Number 6 is going to be flatter by 3/4. And it's going to be a vertical shift down 5 units. So you can look at either the graph or the equation and tell me or anyone the transformations that have been applied to it. Don't overthink this. Yes, it's really this easy. Now this last one, I want you to write the equation of g of x using the transformations applied to f of x equals x. And this is kind of how it's going to be phrased on your STAR test. So f of x is multiplied by a factor of 2. If you're keeping track, that means it's going to be steeper, by the way. It's going to be reflected over the x-axis. Okay. This means we've got a negative slope, which means our m is now going to be negative 2. And then it's translated 4 units down, which means our y-intercept is negative 4. And because we're using y-intercept form here right now, all you have to do is replace your slope and your y-intercept with the values that you found. And this would be your answer. Thanks for watching.